Welcome everybody to SQL Friday. This is SQL Friday number 10, and our star for today is Tomaž Kaštrun. I probably didn't pronounce that correctly, so you'll have to correct me afterwards. Anyway, the session topic is Applied Data Analytics with Azure Databricks. And I'm excited because I never used Databricks myself, so it's going to be a good learning experience for myself. I see people are coming in as we speak. If you didn't see the slide that was on recently, any questions, put them in the chat and I will relay them to Tomaž. And let's take it from there. The stage is yours, Tomaž. Welcome.
Thank you. I'm just going to share my screen. Bam. Okay. Just let me know if you can see my screen.
I can see your screen. Looks perfect.
Thank you. So, good afternoon, everybody. Welcome to 10th iteration of SQL Friday. My name is Tomaž Kaštrun, and as Magnus pronounced it was perfectly. Today I'll be talking about Azure Databricks. Applied data analytics. First of all, we're going to do a quick, let's say, 15-20 minutes intro to what it is, how it comprises comparison to AWS, Azure, and then we'll dive into platform itself with some demos. But first of all, I would definitely like to thank the organizer for making this event possible. Go to Meetup to join the group, and if you're a speaker, call for speaker is always open, etc., etc. Couple of words about me. Well, just read it. If you want to get in touch, there's a couple of ways to do it, so I will not waste any more time on that. So, what is Azure Databricks? For those who, if you have any questions, please write them in chat window, and Magnus will chime in and we'll discuss that. So what is Azure Databricks? It's a platform, Apache Spark based analytics platform available in Azure and in AWS. The story and the history goes, it was first available in AWS and then it was adapted in Azure. The difference between Azure and AWS is that Azure is pretty optimized in comparison to how to put Databricks in Azure versus AWS. It was designed in collaboration with Apache Spark founders, so Databricks is designed by the same people that were working on Spark as well. It is basically one click to set up. It's pretty much interactive workspace. It supports native integration with Azure services, with native integrated Azure security and identity management. Couple of milestones. Last year of March, machine learning flow was introduced and integrated. In June last year, Delta Lake had a huge upgrade. In September of last year, the Databricks version 6 was available alongside with Databricks Koalas. In March of 2020, integration of the models and ML flow, which I'll come back in one of the demos. And in June, literally a month ago, Spark 3.0 was publicly available. On why Spark 3.0? Because it basically has much better performance issues, much better troubleshooting as compared to version 2.xx or 2.11. Why Spark? Because it basically is 100 times faster than Hadoop. It has a highest stability support for Scala, Java, or Python, SQL, Spark, Graph, and a lot of machine learning libraries, and also MLlib, which is a native Spark machine learning package. It is basically open source processing engine, so anybody can use it, adopt it, and it is built on the philosophy of speed, ease of use, and RDD files, especially in the mind of analytics. Spark basically unifies SQL, machine learning libraries, streaming, and graph computations. All of these are basically then poured down into the engine, Spark core engine, and there are a couple of services as Yarn and Mesos that basically takes care of all these loads and communicates through the engine. And there's also the scheduler, basically the sort of like a job enabler that basically can trigger the job or the notebook as it is in Spark. What is the experience with Azure in Databricks? Basically, you can start immediately. You can share and get powerful insights from the Databricks, and you can expose those to Power BI. There is a beautiful integration also with ADF, so Azure Data Factory. There is also very good collaboration with others through used through workspaces and notebooks. And as I said, there is a Azure native integration. It is built on compliant cloud, supports SLAs, uses permission to basically run Azure Databricks jobs, data clusters, and notebooks, and you can literally scale without limits. So there's an asterisk because those scales can come to, let's say, some limitations, but we can discuss this later. So this is a product slide demo by Microsoft. So just to give you a quick overview, what basically Databricks encompasses is a collaborative workspace. You can deploy production jobs and workflows, and Databricks are optimized, basically built on optimized runtime engine. So without, there's no need between data engineer, data scientists, and business analysts to communicate because everything is in the same workspace. You can just dedicate people in the same workspace, share the notebooks, share the data sets. You easily deploy to production. So there's these multi-stage pipelines, which means that you can just sort of like a piping in Python or R. You can just put a lot of steps together in terms of data, in terms of notebooks. You can schedule those notebooks. And then, of course, you have the notification and logs, which basically helps you to troubleshoot. And then there is also the engine itself. It is serverless. It works on APIs. Everything is basically done using Apache Spark. When I say REST APIs, the idea behind is that Databricks itself are running on Java engine. Java engine uses APIs to communicate to Spark. Spark uses APIs to communicate with different types of, let's say, if you're using Python, you can then communicate through APIs to get the data within Python. A couple of differences between Azure and AWS. As I said, Databricks were initially offered in AWS and later came to Azure as well. If I can think about a couple of characteristics, I can say that Microsoft had done much better in terms of enterprise environment ready in compared to AWS, whereas AWS, I think it's a little bit ahead of storage because of the simple buckets, S3 buckets. In terms of security, they are both excelling outstandingly. Connectivity with other services and on-prem services, Azure is again a little bit ahead of AWS, and the rest is literally there. So it's just a matter of the ecosystem, your flavor, and there's also maybe a little bit advantage in favor of Azure when it comes to integration within the cloud provider. But the rest, literally, I would say the main go-getter is enterprise environment ready. How does the scaling work? So whenever you are provisioning a cluster, this cluster basically has a lot of virtual machines in the background. So whenever you are basically through Spark code or through Python, you are saying, okay, do something. This code is then sent down to cluster manager, and this cluster manager then goes and distribute those works to the nodes, and then those nodes have particular tasks to do and get out of the data, do something with data, etc., etc. So whenever you are basically creating a Databricks cluster, you can see in the background in Azure that you will have for each of the worker a virtual machine created. The result of this is then that you don't really need to worry about scaling. You don't need to shut down anything in terms of hardware or services in comparison to HD Insight and Databricks in Azure. For instance, in Databricks, you don't really need to shut down any system. You can just elastically, scale up. Whereas in HD Insight, you usually need to shut down the service to scale it up, and then it takes a couple of minutes to come back. So these are the main differences between when we are talking about Databricks and HD Insight. Also, the worker nodes are using the Delta caching IO transform for data transformation, and they are using also RDD as a resilient datasets, which were initially offered within the Spark, but nowadays everybody is pushing it towards the Parquet files. So in terms of the Azure storage, you can mount Azure storage as a DBFS that is basically a layer over the Azure Blob storage. So DBFS is something that basically is out of the box from Databricks. And based on that, you have a couple of functions that you can just mount the storage and then call this particular data set from storage, etc., etc. So on the bottom sides, left and right, you have a couple of print screens where you can see how to maneuver to particular data set file, CSV, and get those data populated and presented in Databricks platform. You can also use Python, Koala, basically anything via the CLA, which means that you can operate with those two languages also directly to the blob storage. And also data is always persistent in Azure Blob Storage, and it never lost. Basically, it never gets lost, even if the cluster is terminated and deleted. So this is the main advantage is also that you have decoupled the storage and decoupled the computation. So the data and the compute power is always decoupled. So how does Spark work? Explain it like I'm 5. So there is a hint. Those who are using Python, there is a beautiful package called Eli5. Explain it like I'm 5, and I'm just making a reference and a joke here. So imagine you have a lot of M&Ms, and what do you want to do with those M&Ms? Of course, you want to count them. So what do? Basically, you give, just grab a fistful of M&Ms and you give it to a friend, and another fistful of M&Ms and you give it to another friend. So what do you basically do? You are trying to distribute those M&Ms to let's say 5 friends, and those 5 friends are basically then doing their job. So what they are doing, they are counting. So the Spark cluster is basically a driver that basically pushes the loads to the workers. Those workers represented through a node or through a virtual machine that basically has some execution to be done. And those are usually Java virtual machines running on the back. And once I have this, what I need to do, of course, I need to then get all those subsets of a particular function. So let's say subsets of data that my friends have counted those M&Ms, and I need to collect those data back to a centralized, let's say, worker. And this is again done in a similar fashion. And each basically Spark job is then can be represented as a subset of stages that basically does a particular job. So we are basically talking about jobs, workers, nodes that are currently doing those work. As I said at the beginning, Databricks with Spark supports variety of different languages. One would be Hive, SQL, or just SQL. And once you have your data persisted, you can just instance with percentage SQL a particular language that you want to use, and from there on you can start, just switching between those languages. So Spark SQL is supported, and those subsets or results that are coming from, let's say, a Spark SQL can then be interchangeably used with Python, with Scala, with Java, with any different language. And a couple of print screens just to give you a quick idea how this works. As I said, in June of last year, Delta Lake was introduced. Delta Lake is basically a service that helps data engineers keeping the versions of the set of the data sets persistent. So what it does, it basically takes just a data set or a table or a file, and then if there are any changes, it takes care of those changes and it's pushing them either through batch or through operating, from streaming or from batch type of operations, and pushing it into the lake so that you always have the last completed version of data set. Imagine ACID, this would be a synonym for that. So Delta Lake is now available with Databricks, and they are offering it as a go-to tool to fix all of those problems. MLflow was also introduced last year to Databricks. What it basically does, it keeps the track of all your machine learning experiments so that you can reproduce either the model or the code or the data at any given time. This has been absolutely improved with the tracking, which means that you can not only track your code, but also track your artifacts, track your models. It basically works the same fashion as a Git repository or GitHub. So whenever you need to, go back, you can just roll back into the model, into the setting to get the best result. I also have an example on that. So how it does, it basically works as a tracking server, and then you have the registry model registry, where basically you just say, okay, I'm going to push this model from experimental to staging, or from staging to production, etc., etc. There are also a couple of matrices or metrics that you can track the how well your model is working, and you can also do that. So imagine the same way as, say, automated machine learning in Azure. It has the same functionality, and this is MLflow is literally the same. They went even a step further. What they did was they also integrated it through CLA to GitHub. You can run it on Linux, you can run it on your local machine, and it's literally flawless to connect to any type of the service with MLflow. And also Microsoft is doing quite a lot now to integrate MLflow into ADS, so Azure Data Studio. On top of that, those who are into that, Custo SQL was also, part of the whole story behind bringing this sort of continuous integration or continuous development for the machine learner, for the data scientist in Azure Data Studio. As I said, it works as a Git branching idea. The concept is fairly old, quite simple to use. And you also have this sidebar, and I'll have a demo on that, where you can basically just go through all the iterations of a particular model. What does the MLflow contain? As a print, there's a print screen on your right-hand side. The source name, the version, the start-end time of the run. You can also parameterize particular input values, especially very useful if you want to push this into the job. And also you can define matrix or artifacts if you are working with larger models, or if you would be willing to peep your model and with Python and put it in the MLflow. And lastly, analytics. So Spark has out of the box so-called MLlib, which is Apache-based machine learning package that supports native Apache machine learning, basically algorithms and all the functions that a data scientist would need. So basically, not only that it offers parallelized machine learning algorithms, it also helps you, get the data in, how to clean the data, how to measure, how to do the feature selection. Once you run your model, how to do the cross-validation, the training, etc., etc. It is optimized for the notebooks, and you can run Python. You can merge those Python packages also with MLlib, which means that if you are very fond of using matplotlib, you can use that as well. And those print screens on the left-hand side versus on the right-hand side, you can see the difference between the Apache and Spark. So Python Apache, Python Spark versions, they differ a little bit, but at the end, both get the jobs done. It also supports scikit-learn, XGBoost, and many others, H2O, many others very powerful machine learning packages. And in addition, it also gives you out of the box a couple of those very nice clustering, regression, stuff like that, dimensionality reduction, evaluation matrices if you want to do PMML, model exports, model selection, and model tuning. So basically it has, and it comes with quite a lot of out of the box pre-installed functions. You cannot do, let's say, automated machine learning. You would need to either populate it with some Python packages in comparison to, let's say, Azure automated machine learning, where you can basically do, you basically just get the Python SDK and you can do all the automated machine learning with that. So Koalas. Koalas is the response from the data science community because a lot of nowadays data science community is crazy about Python, as it was, many years ago with R or Julia. Python is now the go-to tool, and Databricks have seen this, reaction, and they've been working on Koalas quite a long time, but they've publicly announced it last year on the Spark Summit. And basically what it does is just an API on top of the Apache Spark, and basically it has the same language notation as a Python Pandas. So we are sort of talking about animal kingdom, koalas, pandas. So what's going to be next? I don't know. But anyways, it unifies two ecosystem with a familiar API. What does this mean? In the next slide. And basically, it gives you the seamless transformation between data sets. So imagine for those who are into Python, you would have Python DataFrame in the middle row, in the middle column, and on the right-hand side column, you would have Spark DataFrame. Just to give you an example, how much more Spark would need to be, how much more Spark you would need to write in order to get a, let's say, a value count for particular data set. So this was the thought. The community said, okay, if you want to use a Spark, give us something more useful. So they started working on Koalas. And again, comparison between Pandas and Apache. So for those who are fluent in Pandas, you can understand the code on your left side of the screen. And for those who are willing to write Apache, there's the same code basically that does the same thing, just quite larger. The beautiful part about Databricks is that those two are interchangeable, which means that once you have, for instance, if you use Apache Spark and you want to instance a data frame, you can then say, okay, I'm going to create with Apache Spark a data frame, and then I'm going to convert it to Pandas data frame, or even better, you can convert it to a Koalas data frame. So basically, it is just an API on top of the Apache Spark that what it does, it basically just interprets Spark data frames and represent it in more beautiful manner to a data scientist. So this is a print screen taken from Databricks because it's beautifully visualized how the Koalas data frame work, and it is just a API call to a Spark data frame using internal frames where you get the column index and index map. Unfortunately, I will not be giving you a performance differences between those, but believe me, from the point of usability, it's awesome. So what do you need for applied analytics? So of course, Koalas, Databricks Connect, MLflow, notebooks, of course, notebooks, maybe a book on Spark Hive, PySpark, RSpark, of course, dataset, and Azure subscription. So a lot of those are, I think, no-brainers. Just a couple of words about Databricks Connect. Databricks Connect is something that basically enables you to connect to Databricks from your local machine through an ADI. So you just generate a token. You, first of all, on your local machine, you go through this, basically this code, create a Python environment, PySpark, download the Databricks Connect package, and then get all the tokens and stuff like that to connect to your environment. And then a couple of those tokens and you're set. And you can basically work from your local machine and push all the workloads to Databricks, Azure Databricks, or get access to all those Azure Blob storage files that you want to work with it. A couple of pitfalls. If you go to Databricks website, you will see that some of those issues the Databricks company is aware of, and they are, just openly willing to discuss. But I've had a couple of issues with unresponsive clusters. The problem is that sometimes the cluster just becomes unresponsive, and those pitfalls I'm discussing as a matter of enterprise environment. Why? Because you don't want to have unresponsive clusters, of course. The problem with inheriting schemas on data frames, the problem is whenever you have a wide data set, you might have issues getting the schemas in. So the workaround would be that you would sort of present a schema first to Apache and then load the data in. And then you would have high concurrency cluster. When I was testing it, I've basically realized that it is still not ready for the enterprise. Maybe now with Spark 3, to be honest, I haven't tested it yet. They've managed to fix, but high concurrency cluster is one of two offerings when you create a cluster in Databricks. And basically, they say it will give you the capabilities of multiple and parallel workloads from many data scientists working on the same data set or working within the Databricks environment. But when I was testing it, I wasn't happy with the results. And then you have Azure Functions type of behavior. So I'm still missing that. Let's say Kubernetes or Azure Functions, the same as AWS Lambda. So something serverless that would be able to, let's say I want to scale up to 1,000 virtual machines, and each virtual machine would be working on, let's say, one simulation. So this is still something that is in the making. And of course, debugging was always an issue whenever you have an error or something goes wrong. Debugging in Databricks is something that Microsoft is absolutely aware of, and they are working with Databricks to give end user much better representation of that, but still there is an issue with that. Okay, so we're gonna jump into Workspace. We gonna switch the window now to Azure Portal, and I'll just guide you through a couple of demos, and that's it. If there are no questions so far, I'll just jump onto the Azure Portal.
Nothing right now.
Thank you. So this is my portal. Once you do, you can go to dashboard and just type in the Databricks, and you would have Azure Databricks. If you click on that, it will bring you onto this. So what I've already created is a resource group, and that's it. So once you have this, you can just launch your resource workspace, sorry, and for a split second, you will see that how Databricks is, you can see signing in using Azure Active Directory. So this means that they've done this part absolutely great. So you don't need to worry about security and identity management. So once you have this, on the left-hand side, you would have your sort of like a quick toggle Windows menu bar where you can just go and start using Databricks. For those who are working for the first time, you can drop file here and just create a notebook or just get your common task working. So this would be your home button. In the home, you would have those workspaces. So again, based on your enterprise environment, so since this is my private email and my private account, I don't have any others, but imagine if you would have a enterprise tenant and you would have many users, you could share those workspaces between the users, and then each user would have their own set of notebooks. So everything represented in Databricks is literally a notebook. A notebook is literally just a code file with markdown language and with sections of different code that you want to run on a cluster. So you would have this, the workspaces, and then, as I said at the beginning, decoupled data clusters, jobs, models, and that's about it. So I'm just going to jump into my first demo. I'm going to do intro to Spark. And Before you start, what you need to do is you have to create a cluster. So you can see I have 2 clusters already created. Both are not running, which means that I need to start them. The beautiful part about Databricks is that each cluster will get terminated after a couple of defined minutes of inactivity. So in the meantime, while both are sort of starting, I'm going to just show you how to create a new cluster. It's fairly simple. So you just give a cluster a name, you define a mode. Remember when I was talking about high concurrency, so you have started in high concurrency, you can put clusters in a pool, and then you have the version of the Databricks runtime environment, and then the your typical worker type or what kind of cluster you want to build. So there are a couple of those general purpose, et cetera, type of predefined clusters that you can immediately start working on. Those max workers, mean and max workers are the amount of virtual machines that then a cluster knows how to push the workloads down to a worker. And there are the runtimes, just quickly. Those that have ML at the end, those will come predefined with a couple of those additional machine learning packages. And you can see for the legacy, you have Scala 2.11, Spark 2.4.5, and now also Spark 3.0 or Scala 2.12. So these are all the offerings that you can run your Databricks on. So once you give it a name, just like that, you can create a cluster. So I'm not going to create one because I already have 2. And this is terminate after 120 minutes of inactivity. I can also say enable autoscaling, which means that the cluster will, if it's set in the pool, it will also have the ability to autoscale. So it takes a couple of minutes to just run the cluster. And once the cluster is running, you can just go. As I said at the beginning, the difference between HD Insight and Databricks is HD Insight needs to be stopped in order to be scaled, whereas with Databricks, you don't need to do that. Okay, so going back to my intro to Spark. So this is the definition of the notebook. So notebook is, as I said, is just a JSON file that has, couple of inlines, different versions of languages, etc., etc. You can put in some pictures. I've also seen people, using notebooks as a PowerPoint presentation, using this as a sort of like an instruction for your DBA, for your developer, etc., etc. So each notebook needs to have a cluster attached to it. So since both are still running, but by default, this one is attached to my cluster number 1. So, and then from there on, you are basically just using your Markdown and either Spark, PySpark, RSpark, Hive SQL, etc., etc. So now my cluster is up and running. Yay! I can start working on. So first of all, what I'm going to do is I'm going to get the data. So directly from the GitHub, I've done this. I'm not going to run this, so you can see the result of this data. So I will have some data available. But first of all, I was talking about RDD, and I just want to give you a quick example of what are the RDD files. So first of all, RDD stands for Resilient Distributed Dataset. As I said, those are immutable. So which means that once they are created, you can keep the lineage of those files until, let's say, you either delete them, you join them, there is a failure or something else. So R stands for fault tolerant. The first D stands for it is available across multiple nodes, and dataset is sort of like a collection of partitioned data. But if you want to go on working on faster datasets, there are also DataFrames which are up to 2 to 5 times faster than resilient datasets. So DataFrame in SQL or Python or Scala would be much better. So since we're living in a very strange times now, what I'm going to do is I'm going to talk about so famous topic, COVID. So first of all, I'm going to get the data from DBFS, which is a distributed dataset file system, which is sort of like a layer on top of the Azure Blob Storage, where I will get my data. So I'm just going to run this. And you can see the notebook is attaching to a cluster, and then this should take just a couple of seconds, and then the data will be available. In the meantime, that's strange, takes quite a long time. Maybe kids at home are watching Netflix, and that's the reason why.
Yeah, and I mean, demo time means trouble, always.
Yeah, it's always the trouble, yeah. Anyways, so first of all, it's just going to go, the Spark will go to a CSV file and get those CSV. And then since it is a lazy execution, it will just sort of create a definition until I say show, and this show will then give me the presentation of the file. Okay, so you can see what it does. It basically says I'm going to take Spark job, and those will have basically 2 different stages. Remember, explain it like I'm 5, and those are then sort of sliced to a different jobs and workers. So the representation of my dataset is currently not that good. So what I'm going to do is I'm going to go and say header true and inherit schema. So I'm going to run this again, and this time should be much faster. And I will have the same dataset represented slightly differently with schema, and also the correct dataset. So if I see here, I can click here, I see string integer, string integer. Beforehand, everything was just a string. So just to get the idea, so I was running this couple of hours, so I'm just going to leave it like this. It gives you the number of rows that are currently in this CSV file. So what I'm going to do now is I'm going to try to see what's going on in United States, in Los Angeles, and I'm going to use just simply Spark and say, okay, now that I have my COVID DataFrame, I'm going to go and just say sort it and filter it for the county of Los Angeles. And again, nothing will happen. As I said, something has happened in the background, but since the transformations are lazy and Spark is sort of by definition uses those 2 types of operation, so transformation and actions, nothing has happened because I haven't said, okay, show me the dataset. So what happens in the background is literally whenever I'm saying do sort or do some type of transformation, we are basically getting the data from, let's say, the other way around. So those arrows are pointing to RDD, but if you are talking about where the data set resides, it resides in CSV file, which is then transformed to RDD, and then somewhere in here, this physical planning is happening, and then lazy presentation of the data is basically happening right here. So until then, when I say show me something, actually the Spark doesn't go and start grabbing the data. It just says, okay, this is the definition, and this is how I'm gonna, have the data represented whenever there will be a need to it. So the difference between the previous section and this one is I have .show at the end, and now I will have this data set shown only for the county of Los Angeles. Okay, so I can go and look into the user interface. If I have some problems with my dataset, I can go click here and I will get a new interface for troubleshooting. But let's go and dive into my dataset. So what I'm going to do is I'm going to create a temporary view. I'm going to call it code. And then what I'm going to do is just simply percentage SQL, and I can basically SQL my dataset. I can write, sorry, forgot to run this. I can run, different languages. I can run R, I can write Python, I can use Pandas, Koalas, whatever. I can even use SQL. So this is the presentation of the data. Usually you would get it something like this. And then the beautiful part about Databricks is that you can always visualize the data by just clicking those graphs. So what I've did was I've select the plot options and I put the keys, date, the values cases, and the grouping the county. And I can see the only for the Los Angeles cases, and that's how they were appearing through the time. Yeah, so this is, sorry, the previous one was for all the states, and this one is just for Los Angeles, yeah. And again, I can continue on saying, okay, just bring SQL, since, okay, everybody knows SQL, I can work on that, or I can even, describe it as a graph. If I want to get a little bit more into that, what I'm going to do is I'm going to go to this website and I'm going to grab the CSV file and put it in my temporary folder. All those files would be available under here. So if you click on the data, you would have all those files also available. So I'm not going to run this, but once I have this data presented, I can basically just display the data itself. Again, you can see how the jobs were continuing. All those jobs have a particular GUID number. Whenever you want to troubleshoot or analyze those, you can always analyze those. And you can see my data set is being here. So the next, what I'm going to do is I'll try to merge those two data sets. So on one hand, I have a COVID-19 data set, and on the other hand, I have some information from the census population of the United States, and I want to bring in the number of capita per country and stuff like that. So to get it a little bit of the weighted by population, the number of cases. So again, I'm using, this time I'm not using SQL, I'm using just Python. And I'm saying, okay, from PySpark, take UDF and string and just, create a simple function. And then at the end, just go into dataset and do some transformation with the data. Remember, transformation versus the action. This is the transformation. And at the end, what I'm going to do is I'm just going to put all these things together. And then I can start working and displaying this data set that has a little bit more information as the previous data frame. So in this case, I have also, besides the cases and the county, I also have the population estimate of the particular country, United States country. Continuing on, I can also start working on different data sets, the different columns. I can give it a name, etc., etc. And to sum it up, what I've done is basically I've taken two different data sets, bring it on my blob storage, start working with those, did some munging, did some not really cleaning, but just that. And at the end, I have the ability for a data scientist, to work directly on the data set, use graphical representation. I can always download those export it to HTML. If I can write a report, I can use this, etc., etc. Continuing on, I will just quickly go into 10 minutes of Koalas. This was written in January of this year when the Australian bushfire was apparently using Databricks whenever there is a huge disaster in the world. So I don't know what's going to be next. Probably some data set on Beirut, not really sure. Anyways, what I'm going to do is I'm just going to bring in the Koalas and I'm going to use it's pure Python, Pandas, and NumPy. And what I'm going to do is I will just quickly give you the difference or how those Koalas and Python Pandas are similar. So I can create Koala series, which would be similar to a NumPy series. I can create a DataFrame. I'm not going to run this because it's just a pure demo visual type of notebook. I can create from this series. I can create DataFrame as well. I can, on the other hand, from Pandas create a range, and this would be my time range, and I can create a DataFrame with this range and get the presentation of a DataFrame like this. So basically, I created 2 DataFrames, and now I can go say Pandas DataFrame can be converted to Koala's DataFrame, simply as that. So I say from Pandas, and I put the Pandas DataFrame, and I get the Koala's DataFrame. And I can do the same with Spark DataFrame. I can convert it to Koala's DataFrame. So again, this is my Spark DataFrame. I push it to Koalas, and it's the same. So literally, what I'm trying to show here is that those 2 are interchangeable and very useful, especially for the data scientists, that they don't need to learn Spark. They can use directly Koalas that will communicate with Spark. And on top of the Koala's DataFrames, you can then connect those DataFrames, Koala's DataFrames, to Pandas DataFrames or to any other Python package. There is a beautiful example at the end. Oh, by the way, if you want those notebooks, drop me an email and I'll send it to you. So let's say plotting. What I'm going to do is I'm going to go and matplotlib, instance a matplotlib package, and I'm going to create a series, so Pandas series, just a normal series, and I'm going to convert it to Koala series. So this would be the presentation of this Koala series. It's just one time series, and I'm going to calculate cumulative for each row. And then what I did was I've used this Koalas series, and I say plot this Koala series. So this is where I'm using Koalas and matplotlib Python package. So it means that both are, so Koalas is can communicate with those major Python packages like Pandas, like NumPy, like matplotlib. And the same goes if I have multiple columns. I convert it either from Pandas to Koalas and then plot it in Koalas. And getting data in, getting data out from Koalas, you can also export it or import it to CSV, to Parquet file, or to Spark IO. So this is very short demo, but just to what I want you is to understand why Koalas was born and why there is a need for Koalas. Another demo would be machine learning with scikit-learn. So again, I will not go into details what machine learning is, what type of machine learning we have, because it's currently not really interested. But what I'm going to do is I'm going to take again those code dataset. So again, I'm using just a simple file system and bringing the data in. Then I'm going to import Pandas DataFrame and read this dataset into my Pandas DataFrame. You can see the shape. It has 5 columns and 8,500 rows. And I'm going to instance also the matplotlib. So what I'm going to do now is, first of all, I will try to visualize my data frame. So I'll say, give me everything that was happening on 1st of August, and I will plot those as a scatter plot for all the states in the United States. And you can see this is the distribution of deaths and cases per each of the states. There are a couple of outliers, especially New Jersey, New York, and maybe also California, Florida. I can do this and can leave. Okay. And what I'm going to do is I will say remove those states from my data frame. And again, I have removed, and you can see that the scatter plot now is sort of like more beautiful, understanding the other countries. And I can also see the comparison, New York versus California, how those states have been compared on a simple plot. So I have here California, Florida, New York, and Texas, date and number of cases. And you can see that New York had really hit it hard until, so this date goes until 1st of August of this year. So in the next, I will do a simple regression prediction. First of all, I just want you to understand this. So what I'm going to do is I'm going to take the data set from 1st of March until 8th of April, which means back then the New York State was sort of in, probably not really hit it hard, but there was quite a lot of cases. But then after that there was even more cases, and I will train my model on this data set, which is by common sense, not really good. It could be much better if I would take at least 2 additional months, but then let's just keep it this way. And I will test it, my trained model, I will test it on data set that is everything from 1st of August onward. And I will take the cases and deaths. What I'm going to do is I'm going to take linear regression from scikit-learn, and you can see immediately my formula, number of deaths, what is equals plus multiplied by cases. And you can see I will take training model to create a linear regression function. And then, okay, one hot encoding. I can just skip that since we're slowly running out of time. And check the shape, the categories. I will do the column transformation, everything in Python. And then the famous pipelines, where I can just, sort of like pile together different type of operations for a particular data set. And at the end, what I'm going to do is I'm going to get the coefficients, and then I will say I want to evaluate the number of how my model has performed using RMSE. And based on that, I'm just going to say, okay, calculate this mean squared root mean squared error, and then create a concatenation of original cases and predicted. So I was predicting deaths for particular state for date 1st of August until 4th of August. So this is what I have in my data set until 2 days ago. And you can see, for instance, if I take Washington 2 days ago, it had 1,700 deaths, and my model predicted 2,500, which is extremely bad. And you can also see the RSE is way too high. So what I'm trying to say is, first of all, you can do that beautifully. The problem with my model is that I said at the beginning, watch out, I'm taking deliberately my training data set and my testing data set way apart from what was going on. So that's why I have that bad of a model. And the last demo, just quickly, I want to show you the ML flow. So the ML flow, what I'm doing is basically I am creating a machine learning model, and I want to predict upon with the different input parameters. So what I did was I've created a training validating data set and then some weather forecasting. So what I'm trying to do is I'm trying to predict the amount of production of the energy based on the input of the weather data. So I've run this a couple of times, and remember at the beginning I said if I go under runs, I can get all of my previous runs for my data set. So you can see, so this one in particular, I'm not sure if you can see it. This is what basically consists of my logging and my result of a particular model. So now what I'm going to do is I'm going to jump into ML flow as it is, which will basically give me all the additional information about my model, the matrix I've chosen, and all the model preview. So I have my YAML file, I have all the data, I can have also my artifacts stored here. I can run this just to give you an example of how my loss function was doing. And then this is saved and stored into models. So this is now the tracking system of my machine learning model flow. And you can see, imagine I would have here a couple of models. So the same model, version 1, version 2, etc., etc. And I've pushed this model into staging, which means that, you know, if somebody else that's collaborating on the same workspace comes and says, okay, this model performs good, let's push it to production, then I can push it to production either manually or through the code or through the jobs. The last part is the jobs. So what is a job? Job is a simple cron tab that basically has a diction to run on a particular event, and it runs a particular notebook. So you can see I've created a job that was scheduled to run every full hour, and this is my notebook that basically runs every hour, and you can see it basically fails deliberately every hour. So you can jump in and see what this notebook does, and this is how you then put your notebooks or your models into operation. And every time this job is triggered, what is basically happening in the background is since I've put my cluster into sleep mode after 90 minutes, it does not need to wake every time the cluster itself. But if I would be running this on a daily basis, it would take, you know, additional, I don't know, 30 seconds or so to run the cluster and bring up the cluster and then run the notebook itself. And once you want to do the troubleshooting, this is basically you go to Spark UI and then you can start, you know, debugging your notebook, and that's literally the fastest demo of the Databricks I have ever done. So we've covered jobs, we've covered notebooks, we've covered spaces, clusters, and data, how to start, how to initiate, and that's it. Thanks for participating. Thanks for your patience. If you want to get in touch, Magnus, back to you.
Yeah, thank you. It's kind of mind-blowing what you can do once you get into all the possibilities with Databricks. So It was a nice overview. Needless to say, one would probably need a bit more to get to your level of Databricks, but it was nice to see. I don't see any questions, so now is the time if you have any questions to Tomaž. I'm gonna start sharing my presentation again to the meantime while we look for if there are any questions. Can you see my sharing now?
Not yet. So if anybody has any question, unmute yourself and we can have a open discussion.
Yeah. Now I think you should see my sharing.
Yeah.
So I just want to mention the upcoming sessions for SQL Friday. First of all, I want to thank Tomaž. I agree with everything that comes in the chat, which is nice session from Michal. Koalas also says it's a great session. Eric says great session, a lot of good information, and I agree with everything. It was nice. I would love to explore more. So I don't know if you're doing any longer sessions on any upcoming events, Tomaž?
There are, but if anybody is interested, we can, have a longer session on Databricks as well. So especially, going into this data science, applied data science, we can really dive into that. That would be definitely interesting for especially data scientists. So yeah, we can do that as well.
Yeah, it would be cool to do. I mean, to attend a, I don't know, pre-con or some sort. If you see what I'm sharing, you can see that we have a lot of upcoming sessions, which are also really good. Next week is going to be Thorsten Strauss, who is going to present performance tuning with optimistic concurrency. It's a level 300 session, so it's very much database engine type thing. And just today I finished filling the schedule up to December 11th. So there's one date to go, which is December 18th. So I'm waiting for some submissions for that, and then I will select the last session of the year. And I'm amazed by the interest from the speaker community. So if you are a speaker and you listen to this, just go ahead and come to sqlfriday.net and submit your session. Another thing that is happening in the upcoming months is this. On October 17th, I'm one of the organizers of Data Weekender, the sequel. We did Data Weekender on May 2nd, the first time, and we're doing a sequel of it on October 17th. So just go to dataweekender.com or join the meetup, meetup.com/dataweekender to see what's coming. We'll open the call for speakers in just a few days from now. Next week is Thorsten Strauss on SQL Friday, but the rest of the day it's going to be another event called New Stars of Data, which is all new speakers. None of the speakers have ever spoken on a conference before. Some of them did a user group talk, but no one has talked on a conference. So it's going to be really interesting to see all the new speakers. Some of them I'm sure we will see more of after that. One of them, for example, is Koala, who is going to talk on SQL Friday on September 11th, but he's also on New Stars of Data. So lots of things happening in the SQL community. It's amazing to see what happened with the COVID-19, which you touched on in your DataFrames, but the number of activities that has transformed from physical events to online events. It's nice. You can still keep learning and meet people and so on. But these are two that I wanted to mention especially. Yeah.
Oh yeah. It would be great to meet everybody in person as well. But
yeah,
we have to adapt to that as well. So
I hope we'll come back to that in, well, it's not going to be soon, but eventually.
Eventually, yes.
Yeah, so it's rough on a lot of people. For me, I enjoy being at home because I can spend the lunches, most of them exercising and not having to travel every day, but I miss meeting people so much. So it's, although virtual events are cool, it's not the same thing.
Yeah, true. Sometimes you get tired of those virtual teams and meetings. So yeah.
Yeah, and I think what the Data Platform Summit, what they do with the pre-cons, they split them in 2 half days instead of having full days pre-cons, because it's a bit much to have the, you know, the earphones on for a full day.
Digital fatigue, yes.
Yeah.
That's gonna be a problem, yeah. Okay.
Yeah, so I'm
Thanks.
heading off to do some paid work as well today. But I want to thank you again so much for coming to SQL Friday, Tomaž.
Thanks for having me. Thank you and all the participants, and wish you all the beautiful day.
Yep.
And enjoy the weekend.
Famous last words.
Yeah.
See you, Tomaž.
See you. Cheers. Bye-bye.